show every week. Thank you.
Hello, everybody. Welcome to OpenCV Weekly Webinar. I'm your host, Dr. Satya Mallick, and our guest this week is Meghana Rao, Technology Evangelist of Network Software and Engineering at Intel. Meghana will be giving us a guided tour of how the powerful Intel Developer Cloud can take your edge AI work to the next level. But first, with me, as always, is Phil Nelson. He's the Director of Content and Creative at OpenCV. Phil produces the show, and usually, if anything goes wrong, it is his problem, not just today.
Tell you what.
Hi, Phil.
Yes. Good morning, everybody. It is me once again, the co-host with the co-most, the second banana who is second to none, your plus one and only, but you can call me Phil. It's Mr. Nelson if you're nasty. Welcome to OpenCV Weekly Webinar, episode 82, if you can believe that. I'm here to remind you of a couple things we do every single week here on the show, the first of which is a giveaway to you in the audience. Stay tuned, and later in the episode, I will be asking a trivia question based on the presentation by our guest this week. You will have the chance to win the OpenCV course of your choosing. Stick around for that. We're also taking Q&A from you in the audience, so use the little Zoom Q&A button at the bottom of the window, or ask your question wherever you're watching us, YouTube, Twitch, Twitter, Zoom, etc., 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 and we'll do our best to try to flow it into the conversation. Before we get started today, I want to give a shout out to my best friend Noah, who is in the hospital right now. Get well soon, buddy. I love you. Satya?
Sorry to hear about your friend, Phil. So, Meghana, welcome to the show, and please take it from here. Start with an introduction, and the show is all yours.
Thank you so much for having me, and thank you for the brief introduction. I'm a technical evangelist for the Intel Developer Cloud for the Edge in Intel's Network Software and Engineering Group. And I will be taking all of you through a guided tour of what the Intel Developer Cloud for the Edge has to offer for computer vision application development. But I will also switch to an actual demo mode where I will walk you through some of the interface components of the Developer Cloud for the Edge, show you how easy it is for you to access it and get started, and show some computer vision applications in action. So with that, let me get started. So let's start with just what the future of computing at the edge looks like. There are certain key challenges, especially for developers wanting to deploy applications at the edge. One is to have as less a latency as possible. The second is also because the data sits at the edge, there is a need for enhanced data security and also lower data transmission costs if you have to move data between edge and the cloud. And also having a wider reach and ability to scale your applications. With these challenges, if you also look at the opportunity that is listed on the right, you can see that this is 175 billion kind of an opportunity that we are looking at from corporations just in 2022. And this is just expected to grow year on year. And also, there are very specific considerations for developing an application at the edge that we will also have to keep in mind. So especially depending on what your workload profile looks like, are you building a classification example? Are you building some kind of a multi-streaming capability that involves multiple video streams coming in at the same time? What are some of the specific use case requirements that you could have in terms of requirements for throughput, requirements for accuracy, requirements for the cost and the form factor and the power utility that your application is expected to take, and also in terms of what the optimal hardware architecture is for you to ultimately deploy your application on. And those are some of the key edge development considerations that all developers have to keep in mind. And what we see is one of the areas, or few areas actually, that development teams feel a bit stuck about is AI as a field has existed for a really long time. right? We have had a few winters, but it's as a field has existed for a very long time. So the amount of data and the amount of knowledge base that exists out there can actually be overwhelming. For somebody who's actually getting started, it is very important to really make sure that their learning curve is as smooth as possible. Second, if I'm a developer and I'm developing on a device that is in front of me, I may actually not have access to a variety of edge hardware that I would ultimately like to test my solution on. How do I even know what the right and optimal hardware configuration is that I should ultimately deploy my application on based on some of the considerations that we talked about in the previous slide? How do I get access to some of this hardware so it makes my job of development and testing as seamless as possible? So at this point, let's assume that you have access to the hardware. The paralysis that gets introduced with having the software stack to work very seamlessly with the hardware is the next challenge. For anybody who has done coding for a while, you know that there are quite a variety of software packages out there, different versions of software packages that are required for your application to run. Even if something changes in one area, it is possible that you will end up spending a significant amount of time trying to troubleshoot what actually went wrong and trying to get that entire hardware and software stack to an optimal point where you can again get started with your development and move forward. And also now managing, because we are looking at edge as the area of focus for today, it's also important to kind of look at what the manageability looks like from the area of development to getting it into the form of a cloud native space where you're probably going from application development into containerization, and how do you ultimately deploy it at the edge so it is scalable? What does that continuum between the cloud and the edge look like? So those are some of the challenges that we have seen developers feel stuck at. And this is exactly what the Intel Developer Cloud for the Edge hopes to alleviate. We make
Meghna,
yes.
can I interrupt
Yeah,
slightly?
absolutely. Absolutely.
There are a lot of people in our audience who are familiar with the terms edge and cloud, but there may be a few beginners who may not know what these terms mean. So can we just define what is edge, AI
Yeah,
on the edge
absolutely.
versus
Absolutely.
AI on the cloud
Yeah,
before we move forward?
absolutely. Absolutely.
All right.
So especially, let us look at developing for the edge, right? So let's start with that. So especially at the edge, you may be having sensors that are giving data, right? That you are capturing in real time, and you are trying to make sense of the data in real time, and you're trying to make a decision based on that data in real time. So that is when we say edge, we are closer and closer to the point where you actually see results. And that is kind of the easiest way to define edge. And this could actually be a constrained environment, because let us look at, a traffic kind of an application, for example, right? You may have cameras that are deployed on different street intersections that are giving you data, raw streaming data, right? You could be capturing traffic information, you could be capturing pedestrian information and be able to route traffic in real time. And when all of this data is coming in, how do you actually make sense of that on a device that is sitting pretty close to it? How do I actually provide real-time results using this data without the data having to go all the way to a data center somewhere halfway around the world, right? So that is kind of how we classify between applications that literally sit at the edge. So let's take a completely tangential example, agriculture, for example, right? If you have an application that you are using, that you are deploying on an agricultural field, that is making determinations of whether there is any kind of an infestation on the crop, for example. This is data that you really need at that point. If it really has to go all the way to a different server and some processing has to happen there, and the result has to come all the way back to your actual point where you need the result, there may be a significant amount of delay that gets introduced. And that was the concept of latency that I talked about earlier. So hopefully that gives a little bit of a context to how we define applications at the edge. And one of the key considerations at the edge also, something I would like to just call out here, Satya, is that most of these devices that we ultimately deploy at solutions on at the edge, they're also quite power constrained, right? They're working in low power kind of scenarios, and they need to conserve that kind of power. And these may also not be devices that have data center kind of performance computation ability. So those are some of the key considerations that we absolutely have to keep in mind when we are developing applications that are exclusively going to be deployed in IoT kind of applications at the edge. So hopefully that helped clarify the
And the definition of edge has also moved a little bit over time. Earlier, all the cameras used to be dumb cameras. There was no intelligence. They were just recording videos and sending it to one machine, which was at the location, right? So there would be multiple cameras feeding into a single processing unit, and we used to do it that way. But now, with smart cameras like OpenCV AI Kit, it has moved even further into the edge. So the camera itself has the processor embedded in it, and so a lot of this computation has been offloaded to the camera itself. So Intel's, Keen-Bay processor and MediaTek, they are specifically designed to work at that level, right? Very close to right where the capture is happening.
Absolutely, Satya. I'm so glad that you brought this up. Because the OpenCV AI Kit also, because it leverages the Movidius vision processing unit, right? It has that floating point 16 quantization capability. That is something I actually hope to demonstrate today. So to kind of put things in context about what the developer cloud for the edge helps with, right? So thank you so much for bringing that context up.
Thanks.
All right. So let me go back into the slide deck and talk about how some of those challenges that I addressed in the previous slide are going to be alleviated by taking advantage of the Intel Developer Cloud for the edge. So as a quick starting point, we want developers to have good building blocks in terms of reference implementations, in terms of sample applications. And we also understand that AI is a very is a field that is very proliferant, right? Across industries, we see applications that are being developed and deployed. So irrespective of what the kind of solution is that you could be hoping to develop, what is the most optimal starting point for me? How do I actually take advantage of something that's already done, or take a model that's already optimized for Intel architecture and go forward with my implementation? So I only have to do the changes that I need to do and not have to develop everything from scratch. So the starting point, providing an easy learning curve, that's the first thing. The second, we also understand that going from development into test and evaluation on different Intel hardware, they all have to be on the same platform. So providing a familiar integrated development environment that developers are already familiar with, they've already used that for some of their coding, and making access available to some of the very popular AI toolkits and libraries all on this variety of Intel hardware ready for you to go provides a really good starting point. You probably have had some conversations around the Intel OpenVINO toolkit. So I will show how the developer cloud for the edge actually has OpenVINO pre-installed and how you can take advantage of some of the OpenCV capabilities within OpenVINO toolkit. I will show that also. And again, the last advantage here is having access to this heterogeneous environment. It's not just processing on the Intel CPUs, but how do you actually take advantage of a device that could have integrated graphics in them, or maybe have the Movidius VPU as an accelerator on it? how do I actually make sure that the workload is distributed across all of the compute that is available and manage the resource allocation accordingly? So those are some of the challenges, and those are some of the areas where the developer cloud for the edge actually provides value with. And in this slide, I'm just talking about some of the entry points, right? Not everybody is coming into the development cycle at the point where they already have an application. You could just be starting off, you could be ideating, or you could already have an application that you have built, which you want to optimize, or you may want to come into the developer cloud for the edge and start your application development process. And irrespective of whether you already have something or whether you're hoping to start from scratch, how do you take advantage of the Intel hardware to perform your evaluations on? And that is the baseline evaluation that you're doing. And what baseline evaluation you get is not all you get, because hardware is one component. What is the software advantage that is additionally available to you? That is where you can take advantage of the model optimizer capability within OpenVINO toolkit. You can take advantage of the deep learning workbench that allows you to take AI model that you've built with floating point 32 quantization, for example, and quantize it into floating point 16.8 quantization. So that way the size of your model is actually smaller to be able to deploy on some of these memory constrained edge devices while not reducing the accuracy of the model drastically. Those are some of the optimization in terms of software that you can also take advantage of. So irrespective of what your entry point is, the developer cloud for the edge provides you with a really good foundation. And this is a product that has existed since 2018. And today we approximately have about 100,000 developers using the Intel Dev Cloud for the edge at various aspects of this journey. And also, so we are actually seeing a significant amount of momentum, and that is also how we are able to gauge some of the challenges that developers are facing also, right? And it has been an iterative exercise for us to also make sure what problems developers may be facing and how we can make their process of development so much easier. That's the cycle that we go through. And
so,
again,
Meghna, can I pause here?
Absolutely.
Just to summarize what we have learned, so that let me use my words to explain, so that I'm the proxy for the audience.
Absolutely,
right?
Absolutely, Satya.
Right. So what Intel Developer Cloud, and correct me if I go wrong in any of this. So what Intel Developer Cloud allows you to do is, let's say I want to train a model and I want to deploy this model on an edge device. And for example, we can put OpenCV AI Kit, or let's say Intel Movidius, you want to deploy it on the neural compute stick. What you could do is you could train your model in PyTorch or TensorFlow, and you get a model and you choose the right model for your task, let's say based on MobileNet or something that will fit into the device. And after you have this model is not optimized for the edge, right? So you take this model and you put it on Intel Developer Cloud, and it provides you all the tools necessary to optimize. And there are two kinds of optimizations. One is software level of optimization, where no matter where this model is going to run, you can get software benefits, right? You don't need to know about the hardware. You can just look at the model architecture and do some optimizations like pruning, etc., which will make the model smaller and nicer. So that's one level of optimization. The second level of optimization is hardware level optimization, that based on which hardware it is going to run on, you need another kind of optimization. And this Dev Cloud would allow you to do both of those. So you could choose from one of the many Intel hardware, and you say that, oh, I want to optimize it for this device, and that device may have, let's say, 16-bit quantization. And therefore, you could, you can produce a model that utilizes that. And you can also, Intel, Developer Cloud has all these physical devices connected to the cloud, So you're actually working from your own laptop, but you have access to these physical devices on the cloud. and you follow this pipeline, software optimization, hardware optimization, and then you deploy it on this device and test it as if you had a device available to you right there, right?
Absolutely.
And you could do it for many different devices, right?
Correct. Yeah. So your summary is correct, Satya. And because this is a browser-based environment, right?
Yeah.
All the developers need to do is create an account. When I actually move into the demo piece, I will show how to access and how to request an account. Once they get an account, it's a browser environment. You can access no matter where in the world you are, right?
That's
and
great.
you have access to all the Intel Xeon processors, Core processors, Atom processors, integrated graphics, and the Movidius VPU, all available for you to test your workload on. And in terms of the hardware and software optimization, in many ways, let's look at certain examples. So we talked about camera streaming data, right? You may actually be wondering, hey, how will my application perform if I have 8 different streams that I have to manipulate in real time, right? Versus if I only had 1 or 2 different streams, what is the optimal choice of hardware for me? Would an Intel Xeon processor work, or an Intel Core processor would do, right? Those are the kind of decisions.
Oh, that's great. So I had completely missed that piece, right? That you can try out, while trying out different hardware, you're also selecting the hardware which is appropriate for your task. Right.
And when you come to
having to have all that hardware, which is, tough.
Exactly. Yeah. And when you look at the software piece of the optimization, the software does not, I mean, in some ways, yes, in terms of the model pruning, things like that you talked about, right? During training, because it's more of a heavy duty floating point kind of operation, you really require quite a lot of those layers and operations to really get you the level of accuracy that you need for your model. At inference, all of that computation is not necessary because your model has already learned what it needs to learn. And it's making real-time assessments based on what it has already learned from data that you use during training, right? So it is possible for you to knock off certain layers that are not really adding any more value at the point of inference. That is just software optimization only. But when you look at some of the optimizations, like going from floating point 32 to integer 8, how do I actually keep the accuracy but reduce the size of the model, right? Increase the throughput without really taking a hit on accuracy. Those are a kind of optimizations that are software and hardware centric, because to take advantage of Int8 through deep learning workbench, the underlying processor also has a capability called the VNNI instructions, right? Those are what are actually allowing Int8 optimizations to work seamlessly. So it's more of a hardware and software working in tandem with one another. Yeah. So all of those capabilities, irrespective of whether you are testing raw on any of the Intel processors to see which of the processors even makes the first starting point, and then going into all these additional software optimizations together on top of hardware, you can do all of that. The entire spectrum of evaluation can be done on the developer cloud for the edge. So the one data point that I would just quickly like to call out before I just move forward with the presentation, Satya, you alluded to it. Since this particular developer cloud is exclusively focused on the edge workloads, the input here is a train model, right? You could already have a TensorFlow train model or a PyTorch train model. You could have that model sitting, maybe in an AWS S3 bucket, right? There are connectors from where you can actually pull that model, and then you can perform all of these evaluations and optimizations on Intel hardware on the developer cloud. Or you could choose from the OpenVINO Open Model Zoo, which has about, I think, 150 models across classification and object detection and all of the more prominent computer vision use cases, right? You could choose from that and have that as a starting point too. But I would just like to call out that because this is exclusively edge focused, the idea here is that you have a trained model, you're bringing that in, then performing all the assessments that you actually need to deploy it at the edge.
Right. And just to be, I just want to clarify, get a clarification from you that all this is free for the users, right?
Yes. Yes. All you need to do is create an account, and you'll be given an initial access for about 120 days, and you have the ability to extend that access later on.
Is there any paid version, or you just have to ask for extension?
You just have to ask for an extension.
Okay.
Through the website, it allows you to extend your access. I think you will also get a reminder within about a month of your original expiry date, and it provides you with a reminder, and you can request for an extension in access.
Okay. You still don't have to pay anything. It is just that you request access for more. Yeah, because it's a lot of hardware.
Correct. Yeah, and that's what we want to make easy for our developers, right? So as you can see on this slide here, the conversation that we are having here now, Satya, actually makes for a wonderful segue into what I wanted to talk on this slide, right?
Okay.
So there are multiple types of personas that access the developer cloud for the edge, right? Your intention in what you want to do for evaluation is different depending on who the persona is. If you are a business development or a technical salesperson and you are trying to assess, maybe you've already made investments and you've bought one type of hardware, right? Does that hardware go an extra mile by adding software optimizations? Or if I do need to invest on a new product line, how can I evaluate the performance of my solution on that hardware before I have to make the purchase decision, right? That's the first persona here. And they can do that without having to have any kind of monetary investment done upfront. That reduces your total cost of ownership at the point of evaluation, right?
Right.
The second is if you could be a developer, you could be an architect. Yes, what hardware you're running your solution on is important to that persona as well, but they have an additional angle in terms of what is the best balance in terms of all of this performance, power, form factor, everything that ultimately drives the architecture of the solution that you want to build. That is one thing you can assess also, right? And we also have students and educators using the developer cloud for the edge also. We want the students to be able to come in, take advantage of the open model Zoom models, maybe try some of the projects, class projects using computer vision, test them out on Intel hardware. And most students also have a laptop that has integrated graphics in it, but they may not know how to take advantage of it for vision processing. But when you use the developer cloud for the edge, you test out your model and see, hey, I have a model that is doing some amount of, media encode, decode kind of stuff. That makes the best sense for me to push that on integrated graphics while CPU is actually doing the inference. There is a way to do that, right? And the OpenVINO auto plugin actually allows you to seamlessly move your workloads across all types of accelerators and processing units available on your device. But getting a visual sense of what it actually looks like to even bring your workload and test that out on different Intel hardware and see what the performance is, what types of optimizations you can actually even perform, and what the final output is that you could get all in one place gives significant confidence in how you move forward with your ultimate solution development. And even for educators, right? You could augment your research together with content that's available on the Dev Cloud and use that in your classroom setting. So there are different personas, so like I said, so making the developer cloud for the edge, the hardware and the software stack available together with the different workflows that make the most sense, irrespective of which persona you could be coming in, is the goal. So we want to make that entry point as seamless as possible.
Nice.
A noble goal.
we try, we definitely try. So here is, again, I don't want to spend too much time on this because I really want to be able to show some of the demos, right? But this is just a call out where I'm saying whether you're coming in at an ideation phase or whether you're coming in at the point of just wanting to build your computer vision applications, or you're wanting to optimize it, Or now you have already built your application and kind of building a solution out of multiple applications that you may have developed, and now you're moving closer and closer towards deployment. How do I go into the cloud native space where I build containers out of it that provide for easy orchestration when you deploy it at the edge? Irrespective of what entry point you could be coming in, the data that you see on the right is mapped to that specific entry point as a journey, and there are capabilities available at each. And
Yeah,
this
and I
is
also liked the example that you gave earlier. So when we talk about edge solutions, we often get caught up in where the inference is happening, right? I mean, at least from a computer vision point of view, we mostly think about inference, etc. But there are other pieces of the puzzle that also need computational time. For example, you can do your inference, but after that, you also need to display the results. And if you don't do the video encoding efficiently, then the whole system bogs down, right? And that one example that you gave, that you can use the graphics GPU, the integrated GPU on the device to offload this task. That's a great one, because you want the CPU for inference, and GPUs are better at this video encoding piece. So when you have the complete solution, we'll have to think about the whole thing, the whole package, where everything is going, and not just the inference part.
Exactly. And that is exactly where that architecting piece comes into the picture, right? If you are a solutions architect, how do you actually kind of even modularize, if I may use that word, for your application development in a form that different components can seamlessly move to different computational units? That is a decision that needs to be made up front. Most often, if we don't pay attention to all of these constraints that could happen at the edge, it's possible that we build something that is not being optimally used at the edge, right? So to kind of alleviate those kind of challenges that might happen, we have to take all of these hardware, software capabilities, put them all on the table and figure out what makes the most sense and how can I actually architect my solution in a way that I take advantage of as many components as possible. And that's exactly where the developer cloud for the edge comes in handy. And as you can see here, right, that's kind of what we try to make really easy in terms of if you just wanted to learn how to do certain things. So there is an OpenCV tutorial right here, right? That talks about some of the basic OpenCV computations. But then again, when you put these computations in the context of, let us say, OpenVINO, right? There are certain capabilities that are really critical. So for example, OpenCV is a BGR model, but OpenVINO is an RGB model. How do I actually take the data? You could be processing it in one color format, but the next component could actually require the same data in a different format. So how do I actually take advantage of OpenCV to make some of those data manipulations and make this process as seamless as possible? The second is also, for most people who are in the data science space. I know that the developer cloud for the edge is something we are talking about as an inference, but for those who may also be at an earlier stage within the entire AI pipeline, if you are a data scientist, not everybody has access to millions of data items when you're writing a model, right? You could have a very limited amount of data, and especially in computer vision, you may have to actually synthesize some of the data to create an adequate enough data set that you can then use to train your model, right? Just putting it in the context of a previous project that me and my team were working on, this was a few years ago when there were quite a lot of wildfires, right? And a lot of homeowners had to kind of let their pets go, right? Just to save them from not being trapped in the wildfire. But when the entire scenario kind of eased down, we were thinking about it, what if there is a lost pet and somebody finds it and they want to identify that pet, right? And at that point, it's like we had created a model with data that had zero noise, right? If I have to identify a dog of a certain breed, I use data that is completely clean. Yeah, I could find that on the web. I could have crawled, found, different sources, right? But if I use clean data, there is really no point in trying to keep the same data at the edge, because in the edge, there is a lot of noise in the data. And sometimes you have to transpose the data, right? If I'm creating a model that is actually going to be used in a traffic kind of a scenario, let me say, maybe there has been an accident and the vehicle is actually upside down. I take a picture of it and I want to identify what model of the vehicle that is. But if I actually have only used a showroom version of that particular model of the car, when I train my model, there is really nothing I can do in terms of prediction when it comes to the edge, because the model is only as good as the data. How do I use some of the OpenCV capabilities for like transpose, right? And how do I actually flip some of the original images into different angles and use that for your data pipeline? Things like those, the capabilities that exist within OpenCV. And also transposing of data is also important when you look at the kind of models that you use for inference, right? Different models require different sizes of data. Different models require, the channel, the batch size, the width and the height, all in different orders. How do I actually do those kind of manipulations in a form that OpenVINO can ultimately do its job effectively? And OpenCV comes in really handy there. So providing tutorials and samples that actually connect all of these pieces together and help understand how each process in the pipeline is actually working. So take advantage of all of these samples, right? These are all building blocks that you could use, and just a good starting point. And again, I've talked extensively about this, so I'll not go too much into it. And when you look at optimization through the deep learning workbench, right, this is where you take a floating point 32 model and then you quantize it into an integer 8 model. You have the option to choose which hardware you want to run this on. And if you chose a device that has that VNNI instruction set that is enabled, you can actually get a significant improvement in performance on integer 8 compared to floating point without a significant loss in accuracy. How do you visually, through just the one interface of the developer cloud for the edge, find all of these answers, right? So this is another component. And at this point, I think I have touched upon whatever I needed to in terms of the slide deck. Just a brief list of the hardware that is all available, right? In terms of CPU, you have Core, Atom, Xeon, and graphics, integrated graphics, you have a wide variety. And also in terms of accelerators, the Movidius VPU and the Intel Vision accelerator. This is the exact same hardware that you would also have in an OpenCV AI kit. And that requires a floating point 16 quantization, right? So taking advantage of some of these things on the developer cloud for the edge. And this is kind of how it works in a browser environment, right? You're logging in through a browser. And when you come in, what you have access to is a development server. And the development server is where you would write all of your application. You're also provided a storage server where you can bring in your data set and all of your video streams. But ultimately, when you have tested your application on the development server, ultimately what you would do is also choose a wide variety of hardware to deploy your application on and check your results. And then again, the results are fed through the browser environment. So it's a very simple flow, right?
So
at this
Meghna,
point,
before one more interruption, you
no
mentioned VNNI. Could you explain what it is and a little bit of detail about that?
If I can. So Satya, what I could do is I can explain at a very broad, abstract level. And later on probably provide some resources for the attendees to actually read more about it. Right? So essentially, like I said, software optimizations is one piece, right? VNNI stands for Vector Neural Network Instruction. So essentially, that is the instruction set that is available in some of the Intel processors, I believe Cascade Lake and onwards, that allows for inference applications to take advantage of in-date quantization. So when in software, I actually want to quantize it, it is the hardware that is also making it possible for you to take advantage of. So at a very broad sense, it's an instruction, and it's the software that is enabled through hardware that is providing all of these capabilities. Because there are different types of quantization, right? These are quantization. In-date is post-training quantization that you're doing. There are certain capabilities that, you're quantization aware training. But irrespective of where you're looking at, there is also an underlying hardware capability that would also have to support all of it. So that's the BNNI piece. I can put resources later on, which the audience can definitely read a lot more about. We have a lot published on our community portal that I can point the audience to.
All right, thank you.
Sure, absolutely. So at this point, how are we doing on time? We have 10 more minutes, but I would like to at least show.
You can go long if you have time as well. We're loosey goosey with the schedule on this show.
Okay. I would really like to show at least some of the pieces in demo, right? Because that's kind of, so far we have only been talking, right? Nobody has really seen things in action. So I would definitely like to show at least a few components. I can go about 10 to 15 minutes after if that is allowed.
That's great. So I think it may be a good time for us to do our, user question, audience question.
So that would also give me a couple of minutes to get the demo going then. Because of my power outage, I had to kind of restart the whole process. So why don't I take the time to get the demo going while you...
Okay, and we'll do the audience question right now.
Yeah,
Thank you.
So if you're just joining us for the first time, you need a reminder, we do a giveaway every week here on OpenCV Weekly. This week, we'll be giving away the OpenCV course of your choosing. We're going to do something a little bit different than we normally do. We had a lot of fun with the last Joseph Nelson episode where we, instead of just asking you a trivia question, it was a little more participatory. This one is going to be much the same. You may, before I get to that, this is our friend, the unnamed cat here in the studio. Still tragically unnamed. We really need your suggestions in order to name our feline friend here. Somebody in the LinkedIn chat said the cat was ugly, and that really hurt the cat's feelings. You can tell. Look how it's like really unhappy about it. Please send your suggestions to newsletter@opencv.org. Another thing you may have noticed during the show is that the right ad panel next to the big screen there is rotated 90 degrees. This week for the giveaway, in the Zoom chat, the first person that correctly posts the code to rotate that image will win the OpenCV course of their choosing. Satya, you're going to have to be the judge here because I don't know.
The hint is actually, we even talked about it in one part of the presentation, to be honest.
Yep, exactly. So please answer that. Give us your best shot.
Which photo is it?
It's let me switch the camera to the screen, if you will, operator. Yeah, you can see on the right side there, the AI game show is rotated. So the first person to post in the Zoom chat the OpenCV code snippet.
Let's say you have the image as IM, right? The variable name is IM. Now post the code.
Yep, and we will give
the
you
whole line of code, not just what you're going to use.
All right, this is going to be a demo of the Intel Developer Cloud for the Edge in the next 10 to 15 minutes.
Cool, looks good.
All right, perfect.
The show must go on.
All right. So let me now switch gears from a PowerPoint template to actually showing you all of the things that I talked about. And devcloud.intel.com/edge is the homepage. I will also share the slide deck with all of the attendees after the session, and you should have the URL from there to get started within the deck as well. So when I go to that homepage, this is kind of what you come to, right? Intel Developer Cloud for the Edge. Right now, you see this user icon here at the top right, where I'm pointing my mouse. That is where you actually click and request an account if you don't already have one. And it is important to have an account because that account is what gives you a user ID, which you then use to work through all of the samples. And I talked about a 120-day original account period, right? When you're close to that 120 days expiring, you can request an extension here where I'm pointing my mouse, okay? So if you browse, if you kind of browse down that entire page, there is a video that talks about the different journeys. This video talks very clearly about how you prototype your application using Jupyter Lab, how do you optimize it using Deep Learning Workbench, and how do you go from having an optimized application to creating containers using what we call the container playground on the Dev Cloud for the edge. And for application development, what you would use is all on the left side of the screen: learn, prototype, and optimize. So if you click on tutorials, you will be taken to quite a lot of the tutorials that will show you OpenCV, how to migrate to the edge, how do you use the OpenVINO post-training optimization tool, and some of the optimizations in terms of software that I talked about, right? OpenVINO integration with TensorFlow, how do you do classification, style transfer, things like that. But if you clicked on the sample application, if you come in from whichever vertical, right? We talked about healthcare, we talked about retail, industrial, no matter which vertical you could be coming in through, you have sample applications for you to get started here as well, right? There are different retail examples, there are different industrial examples, healthcare examples for you to take a look at. And also, if you wanted to further optimize your code, these are all the different sections from where you can actually launch the deep learning workbench and do floating point 32 quantization to an n-type quantization, right? So this is a one browser environment from which you can access all of these workflows. And if you are at the third part of the journey, which is building a cloud native application using the Kubernetes-based system, the container playground is what you would be using. And you could get started with the container playground using the section here on the right. So with that, this is a brief walkthrough of the website itself. And I now click on this browse sample applications tab, which brought me here. And for the purposes of today's demo, I'm going to be using the safety gear detection. Okay, this is using a MobileNet SSD model internally. And when I open this up, this is a sample Jupyter notebook. So when I presented the PowerPoint portion of the presentation, I talked about how the Developer Cloud for the Edge provides you with an integrated development environment for you to actually do all of your coding in, right? So this is a sample application. It has extensive amount of comments and markdown in it. So you should be able to follow along fairly easily. There are three components to it. The first is the application, which is this exact notebook. This is capturing a video. It's using OpenCV to do all of the pre-processing and post-processing. It's also using the OpenVINO async API to perform inference. Then there is a developer cloud for the edge component, where after you develop on the development server, this notebook is actually running on the development server that I talked about in the flow. What you do after you develop your application is you choose different edge compute nodes, and then you use the inference engine portion of the OpenVINO toolkit to actually deploy your application on the hardware of your choice. This particular sample could have a subset of the nodes that are available for you, but there are other sample applications that allow access to choosing different examples, different hardware also. And then you have the OpenVINO toolkit itself. So whether you bring in your own model or whether you are pulling a model from the OpenVINO Open Model Zoo, the first step is to convert it into a platform agnostic representation. And that is what we call an intermediate representation, right? Why is a platform agnostic representation even necessary? We want developers to write their application once and not have to make any modifications, irrespective of whether they want to send their workload onto the CPU, the integrated graphics, or to the VPU. It's just one code that you write. When we use the model optimizer, it creates a platform agnostic intermediate representation, which is just a bin file which contains the weights of your trained model, and an XML file which is a description of the topology of the network that you have chosen. And then we have the inference engine, which is a collection of different plugins. So for CPU, you have the MKDNN. For the GPU, you have the CLDNN, and for the VPU, you have the Myriad plugin. It's a combination of plugins that will then take your intermediate representation, and depending on the device that you have specified it to run on, it will deploy it to the CPU, integrated graphics, or the VPU, all seamless. So those are three pieces within this particular notebook. All of the imports, most of you will be very familiar with this. Pre-processing happening through OpenCV. I'll open up that Python code and show it to you later on. And then you have some post-processing, right? And then what we are creating here is for the purposes of this sample, I'm actually using a model from the Open Model Zoo. So as you can see here, I think I briefly mentioned that there are about 100 or 150 models here. Depending on what it is that you would like to do, you can choose from one of this as your starting point. And then I'm using the OpenVINO model optimizer to create that bin and XML file. So if I just look at the output here, just in the interest of time, I actually have pre-run this notebook, right? What you are getting here is a combination of two files. You have two different quantizations available for you here. Floating point 32 bin and XML, floating point 16 bin and XML. So the bin is the trained weights and the XML is the topology of your model. Then you're just creating a job file that has all of the input parameters that are necessary, right? You're setting the OpenVINO paths, some of the different labels, things like that, where the label file is, what the output file needs to be, all of that stuff. And then you actually choose from different edge hardware. Here I have chosen Core i7, one run on the CPU and another run on the GPU. And then Core i5, one run on the CPU, another run on the GPU. And when you look at the results here, right, this computation is complete, this computation is complete also, all three of them, because I pre-run on this hardware, they're all complete. You can get a cumulative plot of what the throughput and latency on all of those different pieces of hardware look like, right? So this is what is the time it took in seconds for you to execute. Because I chose Core i7 and Core i5, I may not really be seeing a significant difference between these. But if I chose a Core i9 and a Core i3, you could definitely see that, you know, the graph that you see here would look quite different, right? And here you could just make your preliminary assessment in terms of, hey, what was the hardware that I got the maximum number of frames to be processed per second? And that would be this. And what did this particular process also take the least amount of time? But in this case, this is the one that took the least amount of time, but the delta is actually pretty minimal, right? You could kind of have a snapshot assessment of what hardware your solution is providing you with a baseline inference on. And this is step number one. But we also understand that it is important for you to not just see a snapshot performance data, but also be able to see system level telemetry. So if you click on this particular telemetry tab from within the notebook, let me quickly see in here.
Brave live demo.
You know, I had actually done all of this ahead of time, and then the power went out. So not much I can do there.
Thanks a lot to the Portland electrical people.
It's actually pretty windy here, so that's probably what caused the brief outage. You know, maybe a branch or something hitting against a power line or something. Okay, so here is the system telemetry that we are getting, right?
Wow.
As you can see, you have CPU utility here, the temperature of the CPU, and this is a device that did not have integrated graphics. Let me go back. This is the first choice, right? This is run on a CPU. The second choice, same Core i7, has a GPU, right? Now let me open up the telemetry for the second one. Here you will actually see that there is some computation that happened on the GPU, and the CPU was relinquished to a certain degree.
All with the exact same code.
This is exact same code. I just deployed it on a different
Very
device, right?
Yeah.
So this is kind of how you can balance your workload on different platforms to see what would be more optimal for you, right? And also because most of the audience here today is all OpenCV, and probably all of you code extensively with OpenCV, I also wanted to open up this tutorial, right? I mentioned there was one tutorial available here with OpenCV.
Awesome.
Most of these are all basic operations on how do you use NumPy, how do you use OpenCV, what exactly does the representation of an image look like? Because ultimately, under the hood, they are all matrices, right? We are operating with matrices. And if it's a grayscale versus an RGB color image, what does it look like? Most of it are all basic OpenCV operations. But further down this notebook is where some of the capabilities that are leveraged within OpenVINO toolkit are exemplified. So for example, I briefly mentioned for pre-processing or post-processing an image, you could be using OpenCV, which requires BGR, right? But OpenVINO requires RGB. There is a conversion that would be necessary from BGR to RGB. This notebook actually shows you how that is happening, right? And there is also, there may also be a need for you to, depending on the model of your choice that you're using for the purposes of inference, right? The image may need to be 224 by 224. A different model might require a different size of input, but your raw data could actually be a totally random size. How do you take an image that is a random size and get it to a point that the model actually requires it to be? You making those kind of operations, they are all demonstrated within this notebook. So for those of you who may be interested in checking out some of these operations within OpenCV, I would definitely strongly recommend all of you to do so.
Awesome.
So that's what I wanted to show in terms of the demo. I also had the deep learning workbench all pre-populated too, but that would take some time for me to bring it back up. But following this webinar, I can consolidate a list of resources and could send that over if you would like to add that to maybe the recording of the session or something.
Yeah, well, we can definitely make sure. Yeah, absolutely. We can definitely make sure that that shows up in the show notes when we upload this to YouTube next week.
Absolutely. Absolutely.
Yeah. Great.
So that's all I had today.
Yeah.
And I apologize.
That's amazing.
Yeah, no, thanks so much. There's some great resources here for the audience. Thank you so much, Meghana, for this presentation.
Thank you so much for having me.
Yeah, I learned a lot. I'm sure the audience did as well. Intel DevCloud is a outstanding resource, especially for things at the edge like this. It seems like there's basically nothing like it. And Intel has this great lineup of different hardware that is optimized for different purposes, for different computes, for different voltages, et cetera, et cetera. And it's awesome for developers to be able to try these things out without having to have a room full of hardware, because that's really where things were for a long time. And so it's really exciting. It's really exciting to see how these things, this is accelerating this industry even more. And I'm really glad that we're here for it. Satya, you want to take us home?
Yeah, thank you so much, Meghana, for this excellent presentation. And I'm pretty certain that people will use Intel Edge Cloud for testing out their, Dev Cloud, sorry, not Edge Cloud.
Absolutely.
Intel Dev Cloud for testing out their models, as well as selecting the hardware that will be used in their applications. So Thank you so much. I really appreciate your presence. And Phil, thank you for organizing this show. And as always, thanks our audience. Unfortunately, the prize was moved to a lucky draw, but please send in your answers. That would be great. And we'll see you next week.
Yeah, maybe.
Thank you all.
Are you sure we're doing a show next week?
Actually, next week, sorry. Next week we are having this, because it's Thanksgiving. we will most likely cancel the webinar because it's
But
Thanksgiving.
we will not be canceling the OpenCV Black Friday sale. And
That's right.
if you want to check that out, you'll be greeted by a horrifying version of Satya as a little gremlin. It's really worth checking out just for that. It now lives in my nightmares. Operator, can we get that outro?
Thank you, everyone.
Thanks so much.
Thank you.
Take care of yourselves out there, everybody. Take care of somebody else if you can, and have a great day wherever you may be.
Thanks.
Thanks. Bye.
All right. Adios.
So Phil, I can
Another
just...
one. You can just close out now. You're good.
All right.
Thanks again
Thank you.
so much. We'll
Take
definitely
care.
try to have you back on the show.
Absolutely. Would love to.